For those of you who haven't met me yet physically, my name is Michel. I speak French, originally from the Congo in Central Africa, and I'm Australian. I'm living in Perth. I did my PhD in geophysics, so I am a geophysicist. A couple of years ago, I worked as a geophysicist in different mining areas. And then I was fed up, tired of doing the same things, which was automated. So every day I could finish my job at 10. And then I was getting paid till 4 p.m. So I said, maybe time for change. Then I ended up working with geologists at the University of Western Australia. The reason I was hired was because very often researchers do a lot of great work, but which end up in publication only. Only the smarter people knows how to turn those publications into business ideas and probably in a place where they would make money for that. And we know that a lot of time we have climate actions, we want a greener future, and then the first people they call in are miners or oil and gas exploration to blame for. And then those explorations happen with the help of sponsors like on the image here, who put their money to our research and get results that will help develop concepts that will help the climate action that other people are calling up. And from the experience of being geophysicists, miners in town are seen as bad guys. So we thought about it and then we said, how can we optimize all the processes that we go from being in exploration and end up with mining? Because what we see as communities is these guys are just digging the ground and then creating more problem for the climate of the land. Eventually, the project I'm going to talk about is about collaboration and using open source as well. The motivation with this project is about trying to create an interface where you as an exploration geologist, you can use and then create a bunch of models. And then if you have a little bit of time, you can do optimization between those models and then pick up the best one. Let's say you want to make a drilling hole, even for water. Then you have to do some exploration. You know where to drill. But every model is wrong. We know that what we produce as a model is wrong. But the fact that we'll create more models, this will give us an indication where to put the next drilling target, for example. So with all the research work done with the Loop, which is the group working a collaboration between Monash University in Melbourne and UWA in Perth, basically they've done a lot of research. It's all geologists for structural modeling. So they produce good 3D model of the regional, at the regional scale, where they can tell you faults, where they intersect. And these are very good information even for city planning. If you're planning your city, if you know where the tectonic plates sit, you cannot take a chance to build a city there. And then this model can give you an indication where the tectonic plates are, or where the faults intersect each other, where the fault offsets are. And now with what we're doing with this package, in UK, they're using it. They're using it for city planning because in my presentation, I will be giving you two packages that we use and we embedded into QGIS. And one of the package, it is just to use the map you get from whichever software you create those maps. And then from those maps, you just put the maps in your package. Then you get very similar to what they call data augmentation or in machine learning or terminology. So the objective is basically building 3D model in a fast and reliable way. We use open source. Why? Because open source, it's free, and if you install it, you own it, you can collaborate, and you can customize it. So we realize that if we want to get solutions quickly, maybe we need more people to kind of use the product we have so that with more queries from different ends, then we can actually get a very scalable solution in that sense. Well, the project is based on loop. A loop, I would say it has 3 pillars. The green pillars, let me just put my pointer. The green pillars is basically a module in which you will create a dictionary of all the available data as information for geology. And then if you go on the red/pink, you have geological and geophysical modeling. So that's another module where you can do the modeling as well for geology or geophysics or jointly together. And the light green one, it is where you do the optimization. Because we know at the beginning every model is wrong, because I can produce a model from this, but if you go 2 meters deep, it's pretty much different. So it's all models wrong. But if you can create more models, you can optimize it and then find a better solution, which will not be the true Earth, but at least it reduces the risk of drilling more pattern within the area that your tenement setting. So for today's talk, I'll be talking about the red block here. So the first engine, it's called Map to Loop. It's open source. It automates maps extraction of geological through augmented different type of data. Let's say if you have a geology polygon, if there are geologists here, they should know. If you have a fault layers or you have a point structure and a digital terrain model, so those are the information we need to do the modeling. So what this map to loop does is it takes one of these layers and then send it through the algorithm and create an augmented data set for you to use for different purposes or application. And it is a library that combines automatically information available in digital maps with conceptual information. Current usage of modeling software manually process this input data. And with this engine, you can do it automatically and it's repeatable as well. So what I was saying is, if we have the 4 layer here, geology, polygon, fault line, structural point, DTM, you can create all these data set as well, which you can see on your QGIS platform. So you create more data, and now that we're talking about machine learning, AI, we need data. So this engine can be used for you to create more data, detailed information from your map. And then you can train from the output of this map to loop model. The second package is called loopstructural. This is a very modular 3D geological modeling library, flexible, it's open source too. It uses full field data set, and one of the advantages that this module has, it's pretty much different to all the existing software, because in this module you can use your geological field expertise to add as a parameters to constrain better your model. And we'll probably see it later when I will show you a demo of the plugin we have developed in UWA. So, again, very powerful. It uses the time aware of different stratigraphic layer. As we know that when during creation we have event tectonic plate or stratigraphic unit goes, they actually lay over each other based on time. If you go to the beach, you will see, across the beach, you see old layers very deeper, and then younger layer on top. So this information is actually captured when you're doing your modeling. So it's based on those constraints. So importantly as well, when you're doing the modeling in this scenario, you can have the information augmented, create a network graph from the information. Here, you can see the link between, let's say, the fault or the stratigraphic unit and how they correlate with each other. So it's just a piece of information you're adding on top of your, if you're doing, let's say, AI, then you can train as well with those correlation. And this on top here is the result from map to loop. And these results are actually used to be input for your modeling engine. So this is very available, accessible on our GitHub repo, and you can access it as I speak. Well, we have all this beautiful research done, and we were like, okay, where do we push it then? That's where we had to think about geospatial packages, and QGIS is one of the most, even more powerful nowadays with all the module and extension you may have. So you just need a little bit of a coder to help you achieve exactly what you want with QGIS nowadays. So we decide to go with it because it's open source as well. This is the homepage of our plugin. You can see on the left-hand side here, these are where you load your layers, and we need 4 layers to actually run the modeling. So you have the geology, the fault, the structure, and it's a very dynamic plugin. So every time you pass one step, some of the push button will be activated. So for example, to get the DTM, you have all the 3 layers loaded first. Then the DTM will come last. Why? It's because we know that these are the main information you need to do your modeling. The reason we made it that dynamic. And over here, it's where you select your reference system coordinate, and you select whichever suits your data set. So because we're talking about modeling, both in geophysics and geology, you need a lot of computer power to run the calculations. So we decided to push the work in the server or local PC like mine, which is quite powerful. You can run it locally if you want to, but we know modeling, usually regional scale, require a lot of computer power. So what we're doing on the QGIS front end, we do the pre-processing of the data. What I mean pre-processing here is because the algorithm has its own language. So we try to do the linking of the data set you have, let's say the table headers you have, and then with the language of the program within the algorithm. And then once you do it on your plugin, then satisfy, you can push those pre-processed data in the server where you have a Docker running there for you, waiting just for you to push the data, and then automatically will start the calculation and send back the result to your PC as well. And we do it for both map to loop and loopstructural, because it can be very time consuming even for map to loop. So this is the demo. You can see you load your project directory. I mean project directory here, it's basically the directory where you will receive your result. And then you select the first layer. The first layer, we have 4 options. You can select from your local PC, the data, or from a server, or from Geoscience Australia server as well. And you do repeat the same process for all the layers. Once you finish, it will create a JSON file format, a dictionary of information which capture all the linking you're telling the algorithm to play with. And then once you do it, you will recreate new data shape files, if you're dealing with shape files, new shape files which are lighter than what you actually started with. We know all the time when they give you raw data, you don't use all the data set. You probably use 2 columns. And because we use dealing with let's say server communication, which needs internet and stuff like that. So the heavier your data, the slower the transfer is. So what we're doing is scrapping it, just picking the row of the column table we need, and then save it as new shape file, lighter, and then send it to the server. As you can see here, we're producing a 3D model. This is at regional scale as the Hammersley Basin in W. And it's pretty simple. So now You just need to click the button to get it working. And it's active and available at the moment. Eventually, we're still on the testing phase, I would say. And we haven't released it in QGIS itself, GitHub repo, but it's available on our GitHub repo. You can use it. Once we have more people testing, then we can think of sending it through QGIS, because the reason it's open source, we want to have a better community so that we can have it handy in a place where collaboration will get. So at the moment, we tested this one on a Docker desktop. So because I don't know if all of you knows, but Docker desktop is just a place where you create like a virtual environment, or let's say a virtual computer. And then the way it's set, when you click, go to map the loop, if the Docker is not running on your machine, then it will create a Docker image from Docker desktop automatically for you. We set it in that way that we're taking away all the pain that coders do go, especially a geologist or geophysicist. So you don't need to do anything. What you need, if you want to use Docker desktop, you just need to have Docker desktop installed on your computer and then launch it. That's it. Then the rest is just normal, straightforward. We have it tested in QGIS server system, which is a HPC cloud, and we tested it in a different box, Linux. We haven't pushed it running for a while, but at the moment I'm planning to launch it in AWS as well. So it's a work in progress, but it should be ready probably by the end of this year. Well, if you like geological modeling a lot, Loop Foundations is running this 3D geological modeling conference for both geophysics and geology in Fremantle next year in Perth. So it's going to be not only things that I presented here, but also 3D modeling based on using physics-informed modeling or machine learning, AI as well. So the tickets are selling already, so if you want to access your ticket or reserve, that would be sweet to see you in Perth, and you've got plenty to do what's there. Otherwise, thank you.
Thank you, Doctor. Interesting presentation. Any questions for Dr. Nzikou? Cool. Thank you.
No worries.
A round of applause again for Dr. Nzikou.